didn't. Is D. All right, cool.
We're trying
Are
to
you doing something inappropriate that's going to cost you your grade in Calculus BC? No. Okay, just checking.
But I found your thumbnail.
You found my thumbnail?
Oh yeah, the picture that people first see on YouTube videos.
Oh, yeah, that's never. Can I get you to look a little less comfortable and maybe join the rest of us? You look like you work here and own the place.
This is where I used to sit.
Oh, that's where you used to sit? Oh, are you that kid?
Yeah.
Yeah. Hi, what's your name?
Matthias.
Matthias, Mr. DeRozier. Nice to meet you. And you can make your own little
Wait, am I
chair.
in the way? If I sit right there?
You guys know Matthias?
Wait,
No,
sit
they
down.
don't.
You sit down. Actively.
Alright, passing these out. And if I could maybe go to my new friends from over here, and your new friends from over here. So sorry. Alright, Carmen, let's call it good. So you can head on over to your session in 5:11. 5:11. Celeste, every now and again, you just go back there and make sure we're actually filming. Okay. Because that would be an epic fail if it did not record. So what session were you guys just in? Mr. Ayers with rate functions.
Yeah.
Did that go pretty well? Okay, so welcome to my session. My name is Mr. DeRozier. I know some of you really well. Others I think I've had conversations with in the past. I have the pleasure of working at Southwest and North Side. I know how convenient. We've got North Side over here. All the Southwest friends are grouped together. Matt goes to Southeast. Braes Oaks. Go. You two. West. Braes Oaks. Yeah, we're going to shuffle you all up in just a little bit. And so if you need to be comfortable for the first couple minutes, that's fine. You're going to make some new friends. Everyone is going to move. All right, so my session is on functional analysis. And I realize you guys are not professional calculus teachers yet, although I really look forward to someday having one of my students become a calculus teacher. Several of them have become math teachers. They work here at ESPrep. Haven't had one yet who's quite made it to being a calculus teacher. I'm going to keep the dream alive. Functional analysis means all those derivative relationships that we studied way back in the day. Way back in the day, f prime, f double prime. I could ask you questions like, f is increasing, and everybody would tell me. If f is increasing, what do we know? F prime is positive. I might say, hey, f is concave down. Can you guys show me what concave down looks like? It's been a while. Concave down, and it looks like this. Some of you are a little bit smaller. Okay, if f is concave down, then the thing that we know about f prime? F prime is decreasing, and f double prime has to be negative, right? There was a time that these ideas were popping. We used them all the time. Now, sometimes we're going to talk about big F. Big F is the antiderivative. All the relationships that we're going to focus on today are about the derivative connections that exist between these functions. I can tell you with pretty high degree of confidence here, about 20% of the questions every single year on the AP exam have to do with functional analysis. Considering how many things there are that we study in AP Calc, 20% is a huge number. I want this to be the 20% where you're like, I am ready for anything and everything that could possibly come my way. This is the goal. We're okay? Now, sometimes we're not going to look at just the antiderivative f prime, f double prime. It might be a rate functions question. You might be talking about f is the number of people that are entering blah, 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 blah. Then f prime is the rate that people are entering. It's how fast. Those are rate function questions too. It could be a physics question. It could be position, velocity, and acceleration. Right? There's a lot of different ways to ask these questions. What I want to do is give you guys the first couple minutes, and here's your goal. For those of you that you just need a couple of minutes to review all the key vocabulary ideas with functional analysis, that's right here. I'm not going to teach this session like you've never seen the things before. You've seen them all before. For those of you that are ready for a little bit more of a challenge, there are these short quizzes that we were doing back in the day. These are just fill-in-the-blank statements. Things that you know about F. What does it mean about F prime and F double prime? Take the next couple minutes, do as much of this as you can. We'll talk in about 3 minutes. About a minute and a half. All right, just gonna take attendance real quick from Braes Oaks. Callie? Callie or Katie? Callie. Maria?
No, she's not.
Maria's not here. Ariana? Matthias? Matthias. And from southeast, we've got Matt. From southwest, Ishmael. No Ishmael. Okay. Michelle. No, Michael. No, Michael. I get their names confused. Pedro is here. Jessica, I don't see Jess. I don't see Sophia. I don't see Crystal, but I do see Myra. And I see Celeste. From west, Karina.
Here.
Karina. Raina. No. Daisy. Daisy. Salvador. No Salvador. All right. Check just a second. And Andre. No, Andre. Didn't I call him? Who did I miss? Brandon. Okay, we've got Northside Brandon. And my friend in the back? Janae. From what campus? Braes Oaks. Janae. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 4. That's 7. That's 8. Wait, that didn't add up right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, I'll figure that out later. All right, so here we go. Let's check these real quick. Number one, if F is concave up, then F prime, everybody is increasing. F double prime?
Positive.
Positive. Okay, F prime of X is equal to 0, then the thing that you know about F is F has a horizontal tangent line. If F has a cusp point at X equals C, then F prime does not exist. If F has a relative maximum at X equals C, then F prime changes from positive to negative. Good. Now, this is where things get a little bit tricky. F is concave down. If I have a graph that is concave down, any tangent line that I draw is going to have to be above the graph. The reason that I care about this is when I look at my tangent line approximations, my approximations are going to be overestimates. Even though I've been teaching calculus for a long time, every time I get to a question like that, I always sketch it out. I'm like, what does that actually look like? And then as soon as I like draw the tangent line, I'm like, oh, of course they're going to be above. Of course I'm going to get an overestimate. All right, after that, if f has a point of inflection, then f double prime changes sign, changes from positive to negative, negative to positive. Change of sign is a nice compact way to say that. If f has a vertical tangent line,
Undefined.
f prime is undefined, even better than undefined. If f has a vertical tangent line, then f prime has a vertical asymptote, which is an example of being undefined, but saying vertical asymptote makes it stronger. If f prime is decreasing, then it has to be true that f is concave down. If f has a vertical asymptote, then f prime also has a vertical asymptote. And then finally, if f has a critical point, that means that f prime is equal to 0 or f prime does not exist. All right, everybody mostly okay? All right, what I wanted to do, I wanted to take just the first couple minutes to like kind of get the juices flowing when it comes to functional analysis, and we're going to launch right into some multiple choice questions. The way that this session is going to run, we're going to spend about 12 minutes looking at 4 really important, really different multiple choice questions that are likely to show up on your exam. I've used them on unit tests before, I used them on your semester exam. These 4 are really good representation of what I would expect you to be able to do. Then you'll have about 12 minutes to work within your groups, although I'm going to move you around, so kind of brace yourself, you're about to move. And then we're going to end with free response. For those of you that feel really good with functional analysis after these 4, I've got some more challenging problems in the back for you to work on. So if you're in Calculus BC at any one of the campuses, you're probably going to want to go to the back. All right, so let's go over this first one. We know that f is the function x cubed minus 6x squared. The question is, when will f be concave up? We know that f is x cubed minus 6x squared, and they're asking me about f being concave up. Concave up, I know you guys all know what concave up looks like. If you knew what the graph of x cubed minus 6x squared looks like, I would assume that this would be very comfortable for everybody. Right? If you know what this graph looks like, figuring out concave up, not too bad. But we don't actually know what this graph looks like. So, what else do we know? F is concave up. The thing that we know about f prime?
Positive.
Not positive.
Increasing.
Right, if you're not sure, go back to that summary sheet. If f is concave up, f prime is increasing. Well, f prime, I know how to find f prime. Right, at this point in our lives, I would hope that this is a really easy question. And everybody can tell me that f prime is? Everybody can tell, not just Celeste. F prime is 3x squared minus 12x, okay? This is f prime. Do I know where f prime is increasing? I don't know what the graph of f prime really looks like. Maybe I could sketch it out. If it was on the calculator, I could look at it. But I don't have that. So let's think one more thing. F is concave up. F prime is increasing. The other thing that you know for sure is that f double prime is positive. I don't have f double prime, but I know how to find it. F double prime is, what is that, 6x minus 12? I can figure out where 6x minus 12 is positive by using something called the number line test. With the number line test, you'd first of all set the 6x minus 12 equal to 0. And then from here, you'd solve it. You could factor out the 6 if you wanted to. And we get x equals 2. 2 is not the answer. Pedro, do you remember, what do you do next?
No.
No clue. Thank you for your honesty. Somebody help me out. What would you do next? Why did we find that x equals 2, Brandon?
Put it back into f of that.
You don't actually want to plug it back into f of x. If your goal is to figure out where f double prime is positive, what we're going to use is the number line test. The way the number line test works, you'd like make your number line. We label the number line. Here's f double prime. what I know is that if x equals 2, the second derivative is positive. The way a number line test works is you pick a point to the right of 2. A good example, right, x equals 3. Pick a point to the left of 2, say x equals 1, x equals 0, and these are the ones that you're going to plug into f double prime. If I evaluate f double prime at x equals 3, 6 times 3 minus 2, what I know is that that's positive. If I pick a point to the left of 2, like 1, 1 minus 2 is going to be negative 1 times 6. It's going to be negative. So the question of where's f double prime positive? Everywhere to the right of 2. So that should be, I can't even see it. That's going to be A, which is somewhere up here in the blue. Okay. Everybody kind of okay? I want to go over these 4 so you've got good examples in your notes. Celeste, is everything okay with the camera? All right, so with that said, let's look at another way that they might ask you these functional analysis relationships. Look at number 2. Take a minute, read this over, get it straight in your head, be ready to talk. Talk to a neighbor if that helps you process.
Oh. This is it.
Make sure you know what this is the graph of. One of the things the College Board likes to do is they'll ask you all sorts of different questions, but they'll give you the graph that you're not thinking about. This is the graph of f. They're asking us to make comparisons between f of 1, f prime of 1, and f double prime of 1. The only thing you see in front of you is the graph of f. Does anybody know anything about any of those 3 values? Anything you know for sure? I'll take anything from anybody. Look at the graph of f. Brandon's got some thoughts. Yes, ma'am.
We know for f of 1 equals 0.
F of 1 is equal to 0. I 100% agree with you. How do you know that f of 1 is equal to 0? You can see it on the graph, and this is the graph of f. This is the graph of f. F has a root at x equals 1. F of 1 must be equal to 0. Love it. Anybody know anything about f prime of 1 or f double prime of 1? Brandon, what do you know?
F prime of 1 has to be a relative max.
F prime of 1 has to be a relative max. I don't agree with you on that. This is the graph of f. F prime would be the graph of the derivative. There is something that we know about the derivative. Yes, sir?
Wouldn't f prime of 1 be 0 too?
Would f prime of 1 be 0 as well? Why are you thinking it's 0?
Because I grabbed f prime of 1.
You graphed f prime, okay? But f prime is the derivative. There is something that we know for sure about the derivative here at this point. What do you know? A horizontal tangent line. If f has a horizontal tangent line, then f prime would be equal to 0. This is the graph of f. F prime, what do you know?
It has to be positive
Why?
because f is in.
The graph of f, what I can say is that f is increasing. Is everybody okay with that? F is increasing at x equals 1, and because f is increasing, what I know is that f prime is positive at x equals 1. F prime has to be greater than 0 here. F double prime? F double prime is usually a concavity conversation that we're having. And if I look at that graph, what's the concavity? Are we looking at concave up? Are we looking at concave down? If I look at the graph of F, this is concave up, not concave up. Concave up looks like this guy here. Concave down looks like the front. This graph, the graph of F, is concave down. It has part of this graph over here. So F is concave down. Concave down at x equals 1. So the thing that we know about F double prime has to be negative at x equals 1. F of 1 is 0. F is increasing at 1. That's why F prime of 1 had to be a positive answer. F was concave down. That's why F double prime of 1 had to be a negative answer. And so what's the right comparison here? Well, if F double prime of 1 is negative, and F of 1 is 0, this guy is definitely smaller than 0. And F of 1 has to be smaller than F prime. So it's going to have to be, is that J? Okay. I did not pick kind questions, okay? I wanted to pick questions that were going to push you, and then we were going to go from there. All right, let's do one more together, and then I want to give you guys a little bit of practice, and then we'll come back together. All right, for this next one, it's going to be really helpful if you have your calculator. If you don't have access to your calculator, I will sketch it on the board, but you really need to make sure that you have regular access to your calculator. Before I sketch a graph, have a conversation with the friends around you. How could you go about solving this problem? This is number 3. If you get your calculator, please sketch that on your calculator. If you don't have your calculator, the graph is coming up. All right. So if you're sketching it on your calculator or you're looking at mine, which graph is this? You gotta make sure you know what graph we're looking at. What graph we're looking at here? This is F prime. The question, number 3, is asking you, what's the question here with number 3? The first derivative is given by that. How many points of inflection? If F has a point of inflection, why did that just happen? If F has a point of inflection, the thing that we know about F prime, if you don't know, go back to that summary table. I need everybody to know this. F is a point of inflection. When you know something about F prime, please raise your hand. One person. If you don't know, go back to that summary table. It's there for a reason. F is a point of inflection. What's the thing you know about F prime? I see 1, I see 2, I need some more. I see 3, I see 4, I see 5. My friend on the way back, what do you know? Let's be really specific. What changes? F has a point of inflection, and it's F prime. That makes a change from increasing to decreasing. There's more to it than that, though.
Or from decreasing to increase.
Or F prime makes a change from decreasing to increasing. F has a point of inflection. F prime changes from increasing to decreasing or decreasing to increasing. This is the graph of F prime. How many times does it change? How many times do we change from increasing to decreasing or decreasing to increasing? It should be 4 times, right? That change happens over here at the max, it happens over here, it happens down here, and it happens down there. It's going to happen those 4 times. You either need to get a sketch of the graph, make a sketch of the graph, and then go from there. So I want to change up my plan a little bit. Rather than doing number 4 right now, we're going to get to number 4 in a little bit. But I want you guys to take the next 10 minutes, find somebody at a different table, ideally somebody that you don't know, somebody that you haven't worked with yet. Your goal in the next 10 minutes is to solve as many of the multiple choice questions as you can. Oh. Please find somebody new to work with. We're finding these friends. Everyone, you guys ready to get? Okay. I missed it. If there are any of you that are like, I really have all this functional analysis stuff under control and you're ready to work on some more challenging problems, meet me at this back table. My friend Myra's not going to join me. That's okay. Myra, you don't have to. Teenagers are allowed to make bad decisions all the time. Okay, so what I have for the two of you are some more challenging functional analysis questions. Right, these are all the like, now it's your response time, and you've got like all the things that are happening. These are going to be hard questions. Do the best that you can before breaking down and checking out my solutions. Okay? And just so that you know, kind of like with any of the other homework assignments, anytime you see a check mark, that would mean like a point earned for doing that. Point earned for doing this, that, the other thing. Okay. Okay, very good. Okay. Okay, talking to my friend Matt over here. Okay. You guys should start on number 5. Sorry, I didn't make that clear. Start on number 5.
Yeah, that's infuriating. What's serious?
Decrease and increase in
I thought it was extreme. What's it make you think of it?
Because of F and
extreme.
But that's when that's when tricky. But it made me look like it, but it's not. So like I put 3.
oh no, I was for that. This is F prime.
Yeah.
So I was just like circling the zeros here.
Yeah. But still but still that's when we're tricky with this.
But it's like something about extreme. It's not like a maximum.
No, like no, like a very temporary. It's like everything like doesn't have an extreme,
I just want to make sure that
and then relative like it's both of them combined.
okay. Why? What's happening?
So you said 3.
Yeah.
Why not just right, so in order to be a relative extrema, a relative max, we need the derivative to change from being positive to negative. To be a relative min, we need the graph to go from negative to positive. This guy actually needs to change sign, that's why this one. And then figure both shows the graph of f prime, function, which one best describes the same interval, so you said one relative min. Why one?
Wait, why would we?
You know there's 3 points of deflection.
Okay, so I said F and G.
Right, because this is the graph of f prime, we're
I
looking
said
for
this
to
is
see
like
where does
either
f prime
negative
change from
and
increasing to decreasing to decreasing.
So there has to be
That
at least
happens
3
once, twice,
because it's either changing from increase to decrease.
deflection. Right. Let's make
Is
sure
the graph
we state that
stable?
as well. How do you know for sure you have one relative min?
9 pi over 4.
No, because so it's almost like this. You know how we find it like either the
So
maximum
if
or
f prime changes from positive to negative,
increase
it's
and
the max.
decrease and increase and
If
increase.
f prime changes
That's
from
the first
negative to
method is I
positive,
found like the total amount of either maximum or
where does the
increase.
relative max
So
happen?
it's either goes this goes from the increase and the increase, and that means that has to be more. This one goes from the increase
So
and the increase
relative
to that
max
or
is
two.
when f prime
It
changes
goes
from
from
positive
decreasing to increasing, so that has to be 3. So that means
It's not here, it's specifically
it's like,
right.
So you
It's
either
this
have-
one
you have to
little
have
point here where
three or
F prime
three.
makes a change from the positive to negative.
you know what I mean? Like you have to have a total of
And
three either
over here,
of
where F prime
extremists
makes a
together.
change from negative.
So that pretty much tells you like there's
It's
gonna
not
be two
on the
related
interval.
variables and
It's
one
in
related
a-
variance. So they give us. So now it's like
Okay.
now you have to figure out convections. And so
Gentlemen, how are you?
every single time it equals zero, that means you have a point of deflection. So I thought it was zero.
Okay, so I don't disagree, I don't agree with you guys here, I also don't agree with you on this first one. I agree with you, it should be between F and Q.
Why is that?
What's this, the graph of?
Is that fine?
This is F prime. So if F
We don't need.
has a relative minimum, what would we expect to see in the graph of F prime? Right, so what you have is a relative max. This is the graph of F prime. F prime at this point changes from positive to negative. Right, F prime is changing from negative to positive, so F is a relative minimum. Relative max over here, relative minimum. So one max, one minimum. In terms of points of inflection, is gonna be like that for you, that multiple choice question we were just looking at. If F has a point of inflection, then F prime, what does F prime do? Not zero. Go back to that summary table. Right, F prime has to change sign. Well, I'm sorry, no, F prime doesn't change sign. If F has a point of inflection, so point of inflection, F has a point of inflection, F prime changes from increasing to decreasing
So
to
that's
increasing to
that's
decreasing. So it's 3 times.
So F prime, when you're looking for maximum minimums, you're not looking for it changing from like decreasing. That's what you're looking for.
For points of inflection, if F is gonna have a point of inflection, then F prime is gonna change from decreasing to increasing.
Okay. Thank you.
Hey, aren't you gonna make, hey, aren't you gonna make like?
It is not
like you
calculated.
Two minimum. Was it like, that's what I think, that's a match up.
Because that's how I was doing it. I was doing it based off of that one. That's why I was like,
And just as per
so
the point.
if we find minimums,
Yeah,
so
but
we're
that,
thinking
right.
we're looking for it where it changes from positive to negative, which is 2 times. No, 3 times.
Friends back here, how are we doing?
Negative to positive right here, then
So,
positive to negative
when
right
you
here,
find-
and then negative to positive.
so when you're finding the derivative,
Because this one doesn't count because it doesn't go.
it's just a function?
Right, but you have to have the 5 pieces.
You don't need
a derivative of an integral of a function from a constant
one
to a
and
variable.
right here it goes from
You need to have the constant in the lower limit and the variable is
negative to positive.
You have all of that.
And
Okay.
it only changes point of inflection like twice.
Yeah, you kind of have to go back to.
It doesn't, I know this is like, it's like a percent state, they twice I went to last week. I just kidding.
And then you can put it to the
I'm sorry.
negative
No.
2.5 to 2.5. That's all we're
Yeah.
looking for. So we don't need any like any extra. This one is yes. So now we have
Oh, it's here.
So you have to find x equals.
Alrighty, friends.
When is x equals?
So I'm gonna share with you guys what the answers are to the multiple choice questions. I don't think many people got more than like 5 or 6 questions done. That's fine. I gave you more than what I expected you were gonna get done. So here we go. I just want to tell you what the right answers are, and then mark it up. Number 5 is B. Number 6, F. Number 7 should be E. Number 8 should be G. Number 9, B, if anybody made it there. Number 10 is H. Number 11 is D. Number 12 is H. And number 13 is going to be A. Okay. Now, the reason I wanted you to have those answers is like as you're thinking, as you're studying, as you're getting ready for the exam that's coming up, these are excellent multiple choice questions for you to look at, for you to practice. I wanted you to know what the answers are. We've got about 21 minutes, and what I want to do is I want to switch gears, and we are going to look specifically at the free response. The free response question starts on page 8. We're going to go over this one for the friends at the back table. You guys can just continue doing what you're doing. You're doing the same thing. You just have some more challenging problems to look at. Okay. These functional analysis questions show up on the free response exam almost every single year. Every free response question is worth a grand total of 9 points. This should be a place where you are really, really comfortable and hopefully is going to be high scoring. Now, one of the things that has started to happen on the AP exam is they're starting to write questions where it like blends together a whole lot of different ideas. It's not just going to be questions about F prime, F double prime, but other things are going to come into play, and it's really important that you're ready for that. So for the next 20 minutes or so, I want to go deep into this question. First thing I'm going to ask you to do is imagine it is the day of the exam. Take 1 or 2 minutes, read through this question. Mark it up. Make sure you know what you're looking at. Take that information and do something with it. We'll talk in a minute. Why is it f of x, why is it not f of t?
Correct.
Because the second fundamental theorem of calculus says if you have the derivative of the integral function, blah, 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 it's the function at the new variable. Really important things to be considering when you first see this. What graph are you looking at? What graph is this? This is the graph of little f. One of my students a couple of years ago, he would write little f everywhere just as a reminder. This is the graph of little f. Because sometimes it's going to be the graph of f prime. Sometimes it's going to be the graph of something else. You have to get ready for this. Other important things, I said we've got horizontal tangent lines at -1. Okay, so at -1, at 1, and at 2 we've got horizontal tangent lines. Horizontal tangent line just means slope is going to be equal to 0. Okay? And something else. They introduce big F, the antiderivative. And they're even kind, they're giving you a little reminder that the derivative of big F is this guy down here, little f. Okay? All right, part A. Find all values of x in the open interval for which big F has a relative